Aram say use science and solve. Don't start speculating. Oh, we have solved similar problem. Oh, this is the formula. Not like that. You see how the problem is and what science you will apply. Enjoy the process of science. Okay. You should enjoy the answer less, but you should enjoy the process of science more. Okay. That is how that is the way you have to do, and you will definitely succeed in life if you do like this.
Option B.
Option B. Okay. Others also do.
Option C.
Somebody got option C, somebody got option B. Okay, continue. Ratio between their volumes. I want more answers. Write the basic formula. See, pressures inside and outside. Okay, so here you have to make one small assumption. What is the assumption you will make? Hello, what is the assumption you will make?
Sir, P0 is 1 atmosphere.
Yeah, P0 is 1 atmosphere. That's a very decent assumption that you have to do, and it's obvious. So if you take P0 is 1 atmosphere, then the excess pressure in the first one will be 0.01 and the second one will be 0.02. Right? Yes. And the surface tension is same because the material is same, everything is same. So therefore the excess pressure is inversely proportional to R. Okay? And if they are asking the ratio of the volumes, volume is proportional to R cube. Okay? So therefore you will have to cube it. So the first one, if you cube it, you will get it as 1 cube. There is, you see, the excess pressure in the first one will be 0.01. Isn't it? 0.01 is proportional to 1 by R. Hello? Sorry, you should not write like this. The excess pressure, I suppose all of you know what I am writing excess pressure. If you don't know, you should ask me. Is proportional to 1 by R. Correct? Hello? Okay. And volume is proportional to R cube. Right? So therefore now you have to cube this. Excess pressure cube. Excess pressure in the first one is 0.01 cube, okay, is proportional to the volume 1, okay, that is R cube 1, and the second one is 0. Okay, sorry, I will little this. So excess pressure cube, I am writing the formula, so I should write like this, is proportional to 1 by R cube, and as I told you, R cube is proportional to volume. Okay, so the first one, so you just have to take the ratio 0.01 cube divided by 0.02 cube is equal to the second case R2, the volume, volume 2 upon volume 1. Correct? Hello? Correct? So this one you will get it as 1 by 8 is equal to V2 upon V1. So they are asking you what the ratio of the volumes V1 to V2 will be 8:1. So this is the right option.
Yes, sir.
Correct? Yes, sir, was a confident answer from Aniket, suppose. And I think Aryan also answered well. Yeah. And others who did not get it, I hope you got it. If you have any issues, you can ask me now. Shall we proceed?
Yes.
Yes. Please give me as soon as you get, you quickly say yes, no, yes, no. Your time will be saved. I can solve more problems. Air bubbles lying just below the surface of water. The surface tension is so and so, and the atmospheric pressure is so and so. If the radius of the bubble is 1 millimeter, then the pressure inside the bubble. Right. So draw the bubble, then life will become easier for you. So what we are telling is, it is just at the surface of the bubble, at the surface. So this is the level of the water. Okay, and this is the bubble, just lying below the surface of water. So obviously the upper pressure will be atmospheric pressure. So they are giving that, and the radius of the bubble they have given. Okay, and the surface tension they have given, right? And the the radius of the bubble is so and so. The pressure inside the bubble, pressure inside the bubble. That's what they have given. Should not be difficult. So they have given this quantity, they have given this quantity, they have given this quantity. You just have to find out the PI. That's it. So, what is the PI value that you get here? So it will be P0 1.013 into 10 to the power of 5. Okay, plus 4 into surface tension. Surface tension is 70 into 10 to the power of minus 3 divided by R2, 1 millimeter. So 1 millimeter is 1 into 10 to the power of minus 3. So those two will cancel. So 470 is a 7 for the 28. So this will be 280. So this 10 to the power of 5, right? Hello? So you want to express this as 10 to the power of 5, then write it as 0.3002. 80. If you want to express this in terms of 10 to the power of 5. Correct?
Yes, sir.
That is, you will get here 280. You will get here 280. But if you multiply and divide by 10 to the power of minus 5. Right?
Yes, sir.
0.0028.
So
10 to the power 5. Multiply and divide by 10 to the power 5.
10 to the power of 5. Multiply and divide by 10 to the power. Sorry.
Plus
10
to
to
0.0.
Yes. You multiply, you will get it in terms of 10 to the power of 5. So you get 1.013, and this you will get it as 0.028.
8.
Right? So
Yes.
you will get it as the pressure is 1.015 something. So they got it as 0.02.
Option B.
Option? Option?
B.
B. Right. Option B is correct. Correct. Okay, got it, friends?
Yes. Yes.
Let me check the option. Which problem is the 23rd, right? 23rd is have we goofed in on calculation? Have we goofed up in the calculation there? It is showing C. B. The option is C. So I thought I'll check it out. 016. I just check it out. Hello? The option they are given is C.
It should be totally balanced because the bubble inside the water.
Air bubble is lying just below the surface of water.
So only one surface in surface. Two things.
No, there are two surfaces.
So one surface. See, it's inside the water. So only one surface provides it.
Just inside the water. Okay, just inside the water.
Yes, sir. Inside the water, sir, there is only one surface for the bubbles. Outside the water will be two surfaces.
Okay, everybody think about it, please. Please, everybody think about it. So if it was inside the water, right? So there is air here and this water. Hi, everybody, please look into this.
Yes, sir.
We'll take two surfaces or one surface?
One surface. One surface.
Why one surface?
So just reverse of water droplets. Like air is inside and water is outside.
Air is inside, water is outside. So this is a air bubble. This is the air bubble. So air bubble. See, if you have taken the soap bubble, then there is air here and air here. Then we are considering two surfaces, right?
Yes, because water has two surfaces, one water and the other.
So this is air inside, this is it. Now in this case, what is it? There is air inside, okay, and there is water outside. Correct? Hello?
Yes.
And that is why we have to take it as one surface. So there should be two. If you take it as two, then it will not be 4, it will be 2, then this will be option C, not option B.
Yes.
Okay? Right. Anyways, this is how we will learn. Two soap bubbles each of radius R are touching each other. Two soap bubbles each of radius R are touching each other. Radius of curvature of the common surface will be. Yeah. Think all of you aram se use science and solve. First get hold of the problem. Draw a diagram.
Yes.
What option?
Sir, I think A option.
I don't like the answer, I think.
Sir, A option.
So he is telling A. Okay. What about others you also think? Aryan, did you draw the diagram?
Yes, sir.
Okay. So correct me if I am wrong. You have drawn one diagram like this and another diagram like this. Both are having radius R, and both are two same soap bubbles, so everything else is same. Now when they come close to one another, when they come close to one another, then what is the physics? What is the physics that is happening? Okay, what is the physics? So if the pressure here was more than the pressure here, then this would have penetrated inside. Or if the pressure here is more, it would have penetrated here. Okay, but the pressures are equal. Correct? Hello? Hello?
Yes, sir.
So under the circumstance, if the pressures are equal, then what happens? The pressures are equal, what will happen?
There should be no surface tension provided.
There should be no surface tension. Why there should be no surface tension? Why there should be no surface tension? I didn't understand that.
Like pressure at both sides is same.
So
Sir, the bubbles will exert same pressure from both sides and the compress.
they exert same pressure from the both sides and they compress.
On the common surface, they
will supply equal pressure on both surfaces. Okay, then what happens? What can be the final shape?
Sir, you draw an 8 figure and line in between, similar.
8 figure.
8 figure, but don't cross it in between.
Don't cross it. That's what I have written here.
No, sir, in between the little flat surface.
No. No. See, you apply physics here. See, now they have come closer. Okay, this is trying to exert pressure. This is trying to exert pressure on each other. Now, this point, this is some material. I mean, the soap bubble is here. The soap bubble surface is here. Hello.
Yes.
So, and they are very close, isn't it? These 2 points are very close to one another. Correct?
Yes.
So you know something called as, if you take a drop of water, so this is a drop of water, and I think I told you, if you take a blade and if you cut this with a blade like this you cut the water and then separate it, slightly separate. Then what happens? As soon as you take the blade out and if the separation is very less, again they will coalesce. You know that? Within a particular radius, again they will join back. But if you separate it too far off, then they will not coalesce. Correct?
Yes.
So that means there is cohesive force between the two. So therefore, what happens here, this and this will have a cohesive force. Okay? And therefore, you might end up getting a surface like this. Correct?
Yes.
Okay? This is possible. This is a possibility. Okay, this is a possibility that can happen, and as a consequence, you can say at this point the radius of curvature is 0. Okay, do you, I mean, in general, if you get a numerical like this, then, how do you, I mean, supposing the 2 radii is given and they will ask you to find the radius of curvature. Supposing here the radius is same, supposing the radius was R1 and R2. Then what would have happened if that come closer? Okay, that is, one bubble is small, another bubble is big, and if they had come closer, then you would be having what? You would be having like this. Correct? Hello?
Yes.
This is what happens because this pressure is more here, pressure is less here, and therefore this is how the thing is. And now the question is, what is the radius of curvature of this, or radius of curvature of the common circle?
So we'll find the difference of pressure between the bubbles and we'll equate it to the surface tension by the radius of the curvature of the circle.
Then what will you get? What will be the radius of curvature of the common this one?
1 by R1 minus 1 by R2.
Good, very good. So you will get it like this. Second, R2 minus R2. 1. Correct? Hello?
Yes.
This is what you are going to get now? Hello?
Yes.
Good, Aryan. You have done a good job. Okay. Now in this case, you see R1 is equal to R2. So numerically also you will get it as infinite. Numerical also you are going to get it as infinite. R common is infinite. Okay. So supposing the radii difference was given, then you could have used this formula and you have done it. And I am very happy that Aryan quickly said, what is the common radius? He used the basic formula and he derived this formula orally. And that's what is the hallmark of a good student. Excellent. Okay, friends, shall I proceed?
Yes.
Please enjoy learning, just enjoy learning. Okay, nothing but enjoyment. Okay, then this effort will get converted to knowledge. 2 soap bubbles, a soap bubble in vacuum has a radius 3 cm and another soap bubble in vacuum has 4 cm. If the 2 bubbles coalesce under isothermal condition, then the radius of the new bubble. Now you see they are very clearly told they will coalesce. That means they will come and, okay, whatever it is. Now don't ask question, sir, in vacuum, how can the bubble be there? It will burst and all the things. You don't have to ask those questions. So they have told it is existing, it is existing. So before somebody could have asked, I have told. Understand the meaning of coalesce. That means, the cohesive forces will act and they will unite and get the same bubble. Understand the difference between the previous problem and this problem. So this is happening under vacuum, and coalesce means they both will combine and form a single bubble. And it will again become a spherical bubble. Okay, that is what is the meaning of coalesce here. So here this bubble plus this bubble will be equal to this bubble. So this is having radius R1, this is having radius R2, this will have radius R2. I hope I understood the meaning of this problem. Under isothermal condition, that means neither energy is given nor energy is taken. So what exactly happens? What exactly happens here? So this has got what?
The bubbles have some particular amount of energy.
Good. So this has got energy S1 and this has got energy S2. Correct.
They combine and there will be no change. The resultant energy should be equal to.
Excellent. So that's it. Because see, isothermal condition, energy. So therefore, you just have to add these two and to get its energy.
Yes.
And the surface tension is also same. Correct? Because the substance is common. Okay, conditions are same. So therefore, then in that case, S1 is proportional to T. S1 is proportional to the area. Correct?
Yes,
S1 because under same tension, because you see here surface tension, you get S by A. So this T is constant, so therefore S is proportional to A. Okay, and so here I will write it as 4 pi R1 square plus 4 pi R2 square. Proportionality constant is T. Okay, it will be 4 pi R3 square. So 4 pi is go, and R1 square plus R2 square is equal to R3 square. So 3 square plus 4 square into raised to 5 square. Right? So, and therefore the radius of the bubble will be 5 centimeters. Got it?
Yes.
See again I am telling you, there is no ready-made formula for all these things. You have to draw the diagram, understand the mechanism, and during the mechanism, what are the physical quantities involved, relevant, and yes, then you should solve. So here you see, the substance is common, so surface tension is same, conditions are same, and therefore the energy must be conserved. That's it. And therefore you just get the problem. Okay, friends?
The word coalesce means they combine. Sir.
Yes. Okay, they will combine. See, that's what I told. You take a drop of water, you slice it into two and slightly separate it and leave it. Again, they will combine because there is cohesive force between the two. Okay, you are not attended my first year classes. Now, I have explained this like this. Supposing to take a loaf of bread and take knife and cut it in the center. The bread will break like this. But again, it will not come back to its original position. In other words, if you take a drop of water, they will come in because there is cohesion. So here you have taken two bubbles and you have brought them close. Okay, it's just like bringing two drops of water close. Okay, then they will coalesce. That is precisely what is the problem.
But in the previous case,
that is precisely the question. So in the previous case, you see, there is a condition given here. Okay, vacuum. There's a condition here. In the previous case, there is no, see, supposing you have taken a soap bubble, small radius and bigger radius. Okay, and when you bring them closer. Okay, so now you have to understand that, well, each molecule here, okay, it is interacting with what? This molecule is interacting with the neighboring molecules. Hello?
Yes, sir.
And this is also interacting with the molecules of air.
Yes, correct.
Okay, but here you see there is no molecule of air outside this. There is no molecule of air outside this.
Yes.
Okay, and therefore, you know, when they come closer to one another, the cohesive forces will be the cohesive force between, see, when this comes closer to this, the cohesive force between them keeps on pulling each of the molecules and till they become one single surface. Because there is no adhesive force outside.
Yes, sir.
Correct? That's why I reminded you.